All right. Settle down here. Okay, I'm going to talk about flow control now. So again, as always, do git pull upstream main. The notebooks should be up there. You should be able to get them. I'm going to go ahead and I'm going to open up the notebook and we clear the outputs so we can kind of run and execute them. So flow control, this allows us to kind of have these conditional statements and control how the flow of execution goes. So the traditional way is Python starts at the top, reads from top to bottom, left to right. It reads each line left to right. But then if you want it to, skip certain lines of code, you can based on conditions, right? So we use conditional statements like if statements, and then we have lines of code associated with the if statement so that certain lines of code will be executed or will not be executed depending on the if statement. And so this is a basic kind of programming concept that I think everyone's already familiar with because you have taken stats 20 with R, and so you have if, else if, and else there. And here we have the same thing. We have if, and then the else if is called elif, and then we have else. All right. As far as the conditions go, we don't use parentheses. We just write if, and then we put in the conditional statement, and then you put in a colon to say, then the following lines are associated with the if statements. The indentation is how Python interprets code blocks. So when it's indented after the colon, those are associated with the if statement. The exact amount of indentation does not matter, but it has to be consistent. Okay, so if you indent using 2 spaces, that's fine, or 4 spaces, that's fine. Okay, I think by default, when you insert a tab, it inserts 4 spaces. Okay, on at least in VS Code and in Jupyter Lab, I think after you type in a colon and you hit enter, it will automatically tab in, but that tab is 4 spaces. Okay, there's but you can also use tab characters. You can use, but it has to be consistent. You can't use 4 spaces here and then switch down to 2 spaces or 6 spaces or things like that, at least within that code chunk. So, okay, so lines indented after the colon are associated with the if statement, and then when there's no longer indentation, it's back to the top level. And so if you want to have kind of an if and an else if and an else, for the else to be associated with the kind of the if, meaning like if this is true and then if it's not or something, then it has to all be at the same level of indentation as the if, right? And you can have kind of multiple levels of indentation. So, this is just a very kind of basic thing. I set the value -3 associated with the name x, and then I do a check. Is x equal to 0? Double equals greater than 0, and then if neither of these are true, then the final statement will print, and it has to be negative. And so here it's going to print out that x -3 must be negative. Okay. And then just like any other languages, the else is only considered if the associated if statement is false. Okay, so this statement here where we're checking if x is greater than 0 versus and here I got if x is greater than 3, this condition will never actually be even checked. It will never be checked. I mean, it will be checked when this is false, okay? But then this will never actually be true because there's no scenario where this thing is false, but this is true, okay? So, it only checks the else if condition when the associated if is thing, okay? All right, you can also nest conditionals, and depending on the situation, maybe it's okay, but sometimes it can be hard to read. So here I've got if 0 is less than x, or if x is greater than 0, and then I have if x is less than 10. So then this, I guess I never, this is actually not true because I never did a check to see if x is an integer, but okay. But basically x is between 1 and 9, right? So we have that. You can kind of combine these things. You can use and, okay? And then that's a logical and. And then you have, you can also, Python also accepts something like this, right? So we have and, we have or. We like to use and or. We spell those out for like if statements, okay? Because if statements are expecting either a true, false, and so you can kind of do a true and false, true or false, things like that. When we're dealing with NumPy, we also have the ampersand, the and symbol, and then we have the vertical line for or. But those are what we call bitwise comparisons, or not bitwise, not comparisons, bitwise and an or, and that's for like kind of applying to a vector. So you can kind of, in NumPy we call them arrays, okay? And it gets applied to kind of all of the elements in the array. So as far as kind of base Python and using your flow control, we spell out the word and, we spell out the word or, okay? Recursion is one of those programming concepts where you name the function, and then within the function itself, you call the function. So here we're defining a function called countdown, and then within the function of countdown, we make a call to the function countdown. And for recursive functions to function properly, you need to have a base condition that will terminate. And so in this case, if we say our base condition is if n is less than or equal to 0, it will terminate with blast off, okay? Otherwise, all right, if it's not equal to 0, less than or equal to 0, we are going to print the number n out, and then we call countdown with a smaller value of n minus 1, okay? And so in this case, you know, we can put in some kind of number like 3. With 3, this is false, so it executes print 3, and then it executes countdown 2, and then with countdown 2, this is false, so it executes print 2, and then calls count on 1, and then with count 1, this is still false, so it prints 1, and then it calls countdown 0, and then with countdown 0, then this is true, and then it prints blast off, okay? And then once it has done that, it returns to the previous call and the previous call and the previous call, and then it does that. Okay, so we get 3, 2, 1, blast off. There you go. Okay. Here, let me. So I'm going to put in this a thing, and you'll see it'll go 3, 2, 1, and then blast off, and then it will say finish the call with all of these, you know, with n equal to 0, 1, 2, 3, or 0, 1, 2. Okay. So after it runs the thing, so basically it's done recursively, and so it starts off with countdown 3. Within countdown 3, we call countdown 2. Within countdown 2, we call countdown 1. Within countdown 1, we call countdown 0. And then when countdown 0 finishes, it prints blast off. And then countdown 0 has finished, so it exits. Then countdown 1 has finished, it exits. And then countdown 2 has finished, so it exits. And that's the end of countdown 3. Okay. Anyway, that's basically recursion there. So you have other things here. This is just print a string multiple times. Okay, so you have a string s, and then again, if n is less than or equal to 0, we're going to return nothing and none, and that will exit the function. Otherwise, we'll print the string s, and we'll call it with n minus 1. And so this is just going to print whatever string we provide it n times. In this case, prints it 3. All right. Okay. And then, you can put in a bigger number, and it just keeps running. Okay. Some functions kind of lend itself naturally to recursion. Things like the factorial function. So factorial function is 4 times 3 factorial, et cetera, et cetera, et cetera. And so there's already a factorial function. I think you can just, I want to say, I think there's already an exclamation point. Oh, wait, no. Maybe it's import math. I forget now. Is it math.factorial? Yeah. So there's already a math.factorial function. But we could write our own factorial function. Again, this is recursively. And the last thing is, factorial of 0 is 1. And so it keeps running until we reach 0. And then we're going to do 1 times all of this stuff. Okay, so factorial 4, that's correct. Factorial 5, correct. Okay, there we go. All right. So anyway, that's recursion. Let me go ahead and give you your first view quiz answer. The letter A. A is an apple. A is an apple. Okay. Now, from a computer science perspective, it is possible to accomplish all forms of repetition using recursion only. Okay, but it's kind of annoying to have to do things that way. So, I don't know if you ever, you could use some of the older programming languages like Lisp and stuff with all of these parentheses, and then you're forced to kind of use recursion for a lot of these things, and it's a puzzle. But we have a lot of these features for loops, like the for loop and while loop and all of those kinds of things that just make things a lot easier. So here I'm going to just create a list, okay, and so basically Python is able to run a loop for any kind of what we call an iterable structure. All right, so iterable data structures are things like lists, basically where you have elements, tuples, which we've seen, also ranges, and even strings. So if you think about the string hello, okay, it treats this as an iterable of individual characters. So you have H, then you have E, and then L, and then L, and then O, and you can perform the iterable operation for each element in that string. So anyway, here I've got a list with the numbers 5, 7, 2, and 1, integers 5, 7, 2, and 1, and we're going to start off with y equal to 0. And this is like a terrible way to go, but what we're going to do is we're going to go through each item x in our list of values. We'll print out x, and then we're going to add x to our running sum y. Okay, and the plus equals operator is the same as saying y is equal to y plus x. So with 5, 7, 2, and 1, we start off with 5, and then we add 7, we get 12, we add 2, we get 14, we add 1, we do that. Okay, here it is for string, and this is we're going to go through each character here, make it uppercase, and add an exclamation point. And so this is not quite an 8 clap, but it's a little. We're going through each letter, and I don't know what space exclamation point. I think that's where you pump your fist without saying a actual letter. But anyway, that's what we have there. Okay. Range object is an iterable. Okay, and so you have something like range 10. Again, Python is 0 indexed, so range 10 is similar to writing like the integers 0 through 9 in R. So you write 0:9 to get like a sequence of 10 values. And you can do something like 100, a million, whatever, right? So this is kind of just like getting a sequence of integers. You can also skip numbers and things like that. Now, Python, again, inherently lazy. So when you say something like range 10, it doesn't actually figure out these numbers. It doesn't go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It just goes, okay, range 10. And then when you want to get those numbers, then you have to iterate through it, okay? So you can say like, all right, for each item in that range, tell me what that item is. We're going to print it out. I say print out the number followed by a space rather than entering a new line. And then it says, okay, that's 0, 1 through, 0 through 9. Okay. As far as the range arguments go, you can change the start and the end. You can also change the step size. So here I'm going to start at 5 and go up to, but not including 10. That the end doesn't include that. So range 5 through 10. If you want to see them, okay, again, this is lazy. So it just says, all right, range 5 through 10. I got it. Okay. And you might wonder, like, why won't it just print the numbers? I just want to see 5, 6, 7, 8, 9. Okay. And that's to kind of just save computing cycles, right? Because you might write range 1 billion. Okay. And in like in R, if you did like 0:1 billion, it's gonna like try to print all of those out. Okay, it's gonna try to figure that out, and that's gonna use up clock cycles. And Python just goes, okay, I'm ready to count to 1 billion when you want those numbers. Okay, but for now, I'm not actually gonna do it. Okay, I think there were like a bunch of memes about like people talking to ChatGPT about trying to get it to count to 1 million and things like that, and then it kind of goes back and forth about. But anyway, again, Python a little bit lazy, or not a little bit. It definitely is, in a good way. That it's not going to waste its time counting to 1 billion if you don't actually need it. Okay. Now, when you say, "Hey, I actually want those numbers, and I want to see them in a list," then Python will go through and put those things in a list. Okay, so here, this is range 5 through 10, and Python just goes, yeah, I'm ready to count from 5 through 10 when you want me to, up to, but not including 10. And here you can say, I need to see those in a list because I'm going to use that list. So you wrap it in a list, and then Python goes, okay, fine, 5, 6, 7, 8, 9, so on and so forth, right? So I'm going to put all of these things in lists just so you can see the output rather than just seeing it as this range 5 thing. So here we're going to say, all right, count by 2, right? And goes, starts at 0, goes up to, but not including 20, counting up by 2. So it's going to stop at 18. Okay. If you say up to 21, right, you're counting by 2. It doesn't actually hit 21. So it will hit 20 here. Okay. It doesn't like if you try to give it something that's not an integer. So if you say 0 through 20.1, it goes, huh? Right? It gives you a type error. It says the type of number, the type of value, type of data you given me here is not okay. All right. You can also give it a negative step. Negative steps will count down. So 10 going down, but not including 5. So we end up at 6. Okay, 10, 9, 8, 7, 6, so on and so forth. Okay. Now, if you want it to count down, you need to specify a negative step. If you don't, it's going to assume step size is positive 1. Okay, so it's saying start at 10, go up to 5, up to but not including 5, and in this case, you're going to end up getting an empty, right? It's going to return back nothing. It's going to say, well, there's nothing in this range here. Okay, and so you get that. And so we have these range objects. They're iterable, and they're very useful. So a lot of times, this is probably kind of the most common shorthand, is just write range 100, and that's the same as I need the 0 through 99. Okay, the other type of loop we have are while loops. Okay, and it just keeps running until the while statement. So while the thing is true, it runs the code, and then when the while statement evaluates to false, it quits. Okay, so if I run this, what is the value of I when all is said and done? Okay. So it prints out I. The last time it printed out I was 9, and then it runs this line of code. I is going to become 10, and then this becomes false, and so it quits out. So I leaves off at 10. Okay. Okay, anytime you're dealing with loops, some of the keywords that are helpful to use are break and continue. Break statements break out of the loop. They stop the loop entirely. And then continue statements will skip the remaining code of the loop and goes on to the next iteration. So here I've got for n in range 20, so that's going to be 0 through 19. Okay, and then in the line of code, it's going to check to see if n is divisible by 2, right? So n mod 2 equal to 0. So is n an even number? If n is an even number, continue. Okay, which means skip the rest of the code. So as far as the code loops go, the rest of the code is print n. Okay, and so when n is an even number, it just goes to the next iteration. So n is 0, it continues, then n is 1. Okay, this is false, so it doesn't execute continue, and it prints out and prints 1. Then it reaches the end of the loop naturally, so then it goes to the next iteration where n is 2. n is 2, this is true, so it hits continue, and it skips the rest of the code, and it jumps to n is 3. With n is 3, this is not true, so it doesn't continue to the next iteration, and it prints out n is 3. So basically, we're going to print out all of the even numbers. I mean, odd numbers, okay? Skipping all of the even numbers. So we have that, okay? Okay, this is just like a simple example where we can run a loop to create Fibonacci numbers. So I'm going to start off with a and b equal to 0 and 1. So a is 0 and b is 1. And then we will set a maximum value at 100. And I'm going to start off with an empty list. Okay. And so while true is going to run forever until we reach a break statement. So our break statement is if our a ends up being larger than a max, then we will quit. Okay. And so this is kind of a little way to do Fibonacci numbers is you just say, okay, if your current number is this and this, then assign b, the larger value, to become a, and then do a plus b and assign that to b, right? So when you first run it, 1 becomes the new a, and then a plus b, which is 1, becomes the new b. And then at the next iteration, we have 1 becomes the new a, and then 1 plus 1, 2 becomes the new b. And then we have 1 and 2, and then, so on and so forth. And then so whatever we get for a, we will append that to our list, okay? And so when we're done, we get Fibonacci numbers, 1, 1, 2, 3, 5, 8, 13, so on. So this is using tuple assignment, okay? We have 2 numbers in a tuple here, and we're assigning them to 2 numbers in a tuple here. Okay, so this is just some handy little things, and then this is we're appending values to a list. Okay, so we'll cover all of these specific methods and things in a moment. Okay. All right, Boolean expressions, these evaluate to true or false. So 5 equal to 5, that's true. 5 equal to 6 is false. 5 not equal to 6 is true. Greater than, less than, greater than or equal to, less than or equal to. Okay. Here I've got the string 5, and then here I have the integer 5. Okay. These are not equal to each other. They are different, right? I could ask, turn this into a string. That becomes true. Could try to convert this to an integer. Okay, and that becomes true, right? But as far as this is string 5 the same as integer 5, no, it's not. Okay. You can also do greater than and less than as far as characters go. All right. And greater than and less than means less than would be, it comes, imagine putting everything in alphabetical order. Okay. Less than means it comes earlier in the list, and greater than means it comes later in the list if you put it in alphabetical order. Okay. Except this is a little bit weird, but this is just how it goes based off the ASCII table. All of the uppercase letters come before lowercase letters. Okay. So A comes before B in alphabetical order. Capital A comes before lowercase a, all right? And all capital letters, okay? So capital Z comes before lowercase a, right? Lowercase a comes before lowercase z as far as alphabetical order goes. I think, let me see. Let's just actually, let's mix these up here. So I'm gonna, if I put, and then I have a lowercase, and then the numbers, and then symbols. Let me see if I can. So sorted, like, okay. So there is some order. This is based off of the ASCII table. I don't know if you guys are familiar with. What's what can I read as far as? All right. Well, this is annoying, but you can see this is kind of the order in which the characters appear, and so you can see like these symbols, these digits, the capital letters, then the lowercase letters, and so on and so forth. So there's actually square bracket comes in between Z and capital Z and lowercase a and stuff like that. So there is like an order behind the ASCII table. So like XYZ, and then square bracket, and then lowercase ABC, and then if I put in, so the order is based off of the ASCII table where the square brackets come in between XYZ. I don't know who determined the ASCII table, but that was decided, like 60 or 70 years ago. Okay. And it's very English centric or American English centric. I don't know what the right word is. Anglo-centric. So it's basically like the US keyboard. All of the symbols that you can type, all the characters that you can type on a US keyboard are part of the ASCII table. But if you have like a foreign language keyboard that does different symbols that are not part of a US keyboard, like, I don't know where they show up in the thing. Okay, they're not part of the regular ASCII table. Okay, logical operators. I think we know true, right? So true and true, true and false, true or true, not false, false or not. So we have all of these things. Okay, I just skipped over this. I'm assuming you guys are good with all of that. Okay. We can check for divisibility using the modulo operator, and this is an idiom to just see if something is divisible by y. So is 6 divisible by 2 and divisible by 3? That's true. What about, is 8 divisible by 2 and 3? It's not. Is it divisible by 2 or 3? That's true. Okay. All right. We talked a little bit about writing functions already, and this is a little bit of kind of strategies for writing functions. I'll let you read this kind of on your own time here. But the idea behind writing a function is you want to kind of take a little piece of code that you will have to run multiple times with slight variations. And if you're going to do that, the function is the perfect case, right? So if it's kind of just like, hey, I want to create this I want to do this operation where I'm going to compute all of these things and produce a table or a chart or something. And I need to do this a whole bunch of times, but I want to do it for this variable, and then I want to do it for this variable, and I want to be able to do it for different things. A function is kind of a perfect use case for that. My general rule of thumb is, so we always have the task where it's like, okay, I want to repeat this again. So you kind of like highlight your code, you copy it, you paste it, you change a couple things, and you run it again, okay? So if you copy and paste it once, that's fine, okay? My general rule is by the time you copy and paste it a third time, then it needs to be a function, okay? So the same kind of code shouldn't appear, like you copy and paste it once, so it appears twice, that's okay. Copy and paste it 2 times, so the same code appears in 3 locations. That's like the limit of where I say I draw the line for copy and paste. And by the time you're like, okay, I need to do this again, a 4th time, so I'm going to copy and paste it a 3rd time, that's when you go, you know what, let's turn it into a function, okay? Turn it in, that's kind of my, because that's the use case for a function. When you find yourself copying and pasting code, turn it into a function, okay? So this is just like, oh, here we're going to make a function for drawing a square, and this is just imagine some kind of thing where you're giving instructions to a pen, and you're going to go forward, you're going to turn left 90 degrees, and then you go forward 100 steps or whatever, you turn left 90 degrees, and so on and so forth. There's actually a little program in Python called Turtle, and it will draw things like this. I don't have it here, but you can load this up. And so this is, so if this is one way to draw a square: go forward, turn left, go forward, turn left, go forward, turn left, and so on and so forth. And this will draw the square. And you see, well, see, we've copied and pasted these 2 lines of code: go forward, turn left, go forward, turn left. We've copied and pasted it, 3 times. And that's where, okay, well, let's put it inside a loop, okay? So it runs it 4 times, and then we'll encapsulate that in a draw square, okay? We can then generalize by replacing the number 100 with a variable length, all right? So now we can have each side of the square be, whatever length we want to specify. And then we can say, well, all right, what if I don't want to just have squares? What if I want to have regular polygons? And, the rule for how much you turn as far as a regular polygon goes, depending on the kind of, so the internal angle in terms of like, if you are like a little turtle drawing these things, at the end of the polygon, you would have done a full circle, so you would have run 360 degrees. So as far as all of these other things, you can kind of take however many angles you want, do 360 divided by that many angles, and so on and so forth. So, with a hexagon, the internal angle is 120 degrees, okay? But then the external angle, as far as like, you're leaving a trail behind, it's the complementary angle of 120, which would be 60. And that's how we're getting 360 over 6. And so anyway, we can generalize this, and we can say, all right, if we want to draw a polygon, we can say what's the length of each side, and then how many angles do we want, okay? And so so we can do that. All right, but let's go ahead and start talking about lists, because this is going to be one of our key data structures that are going to show up in lots of places in Python. Let me give you second answer, right? Okay, I've only given you one answer so far. Okay, second answer is the letter B. B as in bear. B is your second answer. Okay, so as far as lists go, we define them with a single square bracket. Okay, square bracket, and inside the list you can put in different kinds of data types. So you can put in strings, you can put in integers, you can put in floating point numbers, and so on and so forth. So this is just some fictional list with a fictional family people. We got people's names and then their height in meters. Okay, just making up some things. Okay, and that's a list. You can also put nest lists inside other lists. So fam2 is a list of lists. The top level list has 4 items in it. Okay, and each of those items are a list of length 2. Okay, so fam2 is a list of lists. All right, and so when you print out the top list fam, that's a list of length 8. And then fam2 is a list of length 4. It's 4 lists of length 2 each. Okay. When you have a list, if you want to reference any of the items, you can subset. Okay. Everything in Python is 0 indexed. So you just subset using square bracket. This is very similar to the way we subset a vector in R. So you say, hey, I want the first item, the 0 index value of this thing in fam, which is going to be the string Liz. Okay. Fam2, which again is a list of lists. The zero index element here is this list of 2, which is going to be a list containing Liz in 1.73, right? And so because fam2 is a list of lists and fam2 square bracket 0 returns this list, we can then reference items within here, and I can say fam2 square bracket 0 here, and that's going to refer to the string Liz inside this thing here. Okay. You can also give it negative indexes. Negative indexes count in from the end of the list. Okay. So as far as fam goes, this is, so counting forward positive, this is index 0, 1, 2, 3, 4, 5, 6, 7. Okay. Counting backwards, this one is negative 1, negative 2, negative 3. Okay. There's no negative 0. Okay. There's no negative 0. That's just, I think that's just 0. But negative 1 counts in from the end. Okay. Here. Have I ever done negative 0? Yeah. Negative 0 is just the same thing as 0. Okay. So so negatives count in from the end. Okay. fam2 negative 1 would be the last element in there. And then so if I do negative 1, it's going to reference this value 1.89. Okay. If you want a range or within the list, we call that a slice. Okay. And so you slice using the colon. And so basically here, fam1:3 is going to slice from index 1 to position, to index, I guess you can kind of think of it as position 3, or think of one way that I like to think of slices is you are slicing at the comma locations. Okay, so slicing from 1:3 is we are going to cut at the first comma location, ending at the third comma location. So the result of this is going to slice out 1.73 and Emma. Okay, because you're basically slicing at the comma locations. So slice at comma location 1, comma location 3. So we do that. Okay. If you say 1:2, this is basically the same thing as index 1. Okay, you're slicing from comma 1 to comma 2. We're just going to get out that number 1.73. Okay. There is a difference though. When you slice, it returns a list. Okay, this is a list of length 1 containing the value 1.73. Okay, whereas fam square bracket 1 returns the element, the object at index position 1, which is the float 1.73. Okay, so there's a distinction, but you know the slice here is basically not extracting out, but slicing out the element there. Okay, not the element, the list there. If you try to do a slice with a comma here or colon here, you do 1:1. Okay, basically you're slicing from comma location 1 to comma location 1. And so that's going to give you back a list with nothing in it, okay? An empty list, okay? 0:2, we're slicing at from, I guess, comma 0, which would be before our first element, to comma 2. This is going to give us our Liz in 1.73. Okay, 6 through 8. Where did the thing go? Okay, so we're counting 1, 2, 3, 4, 5, 6. We're going to start at dad, comma 7, and then comma 8. There's no comma 8, but it's at the end of the list, so we're going to get out dad in 1.89. Okay. Okay. If you do a slice and you just leave it empty afterwards, so 2 colon is going to start at comma location 2, and then give you everything to the end. Okay. And then blank colon 4 will start at comma location 0 up to 4. Okay. And then if you do a colon here, okay, square bracket with a colon, no indices at all, it's going to slice all of the elements, and this will create what we call a copy of the list, or a shallow copy of the list. All right, and there's things known as shallow copies and deep copies, and we'll talk about that later. Okay. If you try to use the subsetting operator, the square bracket there, but you don't provide any index, okay, Python gets upset with you. It says that's not allowed. Invalid syntax. All right. Negative indexes, we're counting backwards. Okay. So if I say -5 to -2, so counting backwards, we count 5 commas back. 1, 2, 3, 4, 5. So we're going to start at 1.68, going to 2 commas back. Okay. So we go from 1.68 to 1.71. All right, same kind of thing. Here's the list of lists with FAM2. All right, so 1:3, we're going to end up getting the list of 2 with the elements for the EMMA 1.68 and MOM 1.71. Okay, and then this one is like, okay, well, what if I do this? So this is just like, so we're just kind of chaining our subsetting operations. So 1:3 will return this thing. Square bracket 0 will be this index, or this list of length 2. And then 0:1 will get out the first element there. So we'll get a list containing EMMA. Okay. So play around with this, study this, learn these things. It's important to be able to anticipate what Python is going to return as you're reading kind of code and seeing how it's like referencing list indexes and stuff. You're going to want to be able to anticipate all that. Okay, let's see. We're going to run out of time soon. Let me give you your third view quiz answer. Third view quiz answer is the letter C. C as in cat. Let me just check real quick. I think I'm going to... Okay. So we'll start talking about this concept that lists are mutable, and we'll continue this on in Friday's lecture. But list objects themselves are what we call mutable, in that when you have a list that exists in memory, you can change that object in memory itself. Okay, and all references to that object will change. Okay, so here I'm creating a list. Okay, this list of length 8 containing FAM, and then I'm going to say second equals FAM. And so the name FAM is pointing to this object in memory. The name second is pointing to the exact same object. Okay, so we have 2 names pointing to the same object here. So what is going to happen here is I'm going to change the value at index 0 from Liz to sister. Okay, so the list in memory now is going to be sister 1.73 Emma blah blah blah. Okay, and then so the name second points to that list. The name fam points to the same list. So both things, second and fam, are going to be modified. So here, what you're going to see is we're going to print out the first list with containing Liz. We do run some code that changes that first element from Liz to sister. And then when we print out the resulting list, we print out second, which points to the same object, and fam points to the same object. Okay, so we're going to see Liz come out there from the first list that gets printed. And then second is this thing. And then if I say fam, print fam, it's pointing to the exact same object. So again, we get the exact same thing there. Okay. That is different from this code. Okay. So here I'm reestablishing, I'm creating creates an entirely new list. Okay, so we're abandoning these things over here. We're creating an entirely new list. I'm calling it fam, okay? So the name fam now points to this new list. We're going to print it out. Second here is going to create a copy, all right? So this creates a copy. So this is not the same object. So I have the list fam here. Second is going to create a copy of that. So now I have two things here. So then when I call change element 0 and second to sister, and I print that out, that's going to be different, okay? But that first list, fam, is unchanged, okay? We'll go over this again, all right? So we have Liz and we have sister. This is the second one, and we have Liz referring back to that first object, okay? So we have different objects here, all right? Here I can create a copy. So fam is still pointing to this object, which is exactly the same as this one, right? And we can do fam here. Another thing you can do, I guess, there's a function called ID, and this is like the name in like the ID number of the objects in memory. Okay, and so these have two different IDs, indicating that they're different objects. Okay, whereas when I run, if I run this code up here, and I say, what's the ID of fam up here? It gives me an ID there. And if I say, what's the ID of this? Okay, remember in this code, second and fam are pointing to the exact same object. Okay, so when I ask, what's the ID of this? It's going to be the exact same object here. Okay, so you can see that they have two IDs here. So the same ID here. Okay, whereas over here, when I run this command, this creates an entirely new list. Even though it has the same contents as this stuff, this command creates a new list, right? The single square bracket here says create a new list, and that's going to give it a new ID. Okay, so if I ask for all of this ID is going to be entirely different from what we had there, and this ID is going to be entirely different as well. Okay. Yeah, so this is just coincidentally, it ends up with 304, but it's a different ID, 186803, and this is 186802. Okay, so we have different IDs here. So that's, but anyway, we'll explore this a little bit more on Friday, this idea of mutable lists and copies and deep copies and all of that. So we'll leave off here. I think I gave you all 3 review quiz answers. Yep. Okay, so we'll wrap up here. Have a great rest of your day. We'll see you on Friday. Yeah, question? Yes, I've reached out to the TA. There should be a TA section tomorrow. If not, let me know. But there should be a TA section tomorrow.